Okay guys, so today we're going to start out with 5.1, adding and subtracting fractions with like denominators. Now this is a 4th grade skill that I've recognized we need to work with before we move on to the 5th grade skill, which is unlike denominators. So here's your 4 problems. If you want to try them first, you can, and then you can check your work with me. Okay, so let's start out first. 11/7 plus 5/7. Now you do not have to draw out what I'm about to draw out, but if it helps you, by all means. I just want to make sure you see why it works the way that it works. Okay, so I'm starting out and I'm cutting my holes into sevenths because that's what these fractions say. Okay, and this first one I'm going to say, all right, I have 11/7, so 4, 5, 6, this is 7/7, one hole, 8, 9, 10, 11/7, which I can actually see here is 1 and 4/7 is 11/7. But then I have to add to that 5 more sevenths. Now there's a couple ways you could do this. I'm just going to do it. Now I'm going to do it in a different color, although you wouldn't have to. I'm going to add 1, 2, 3, 4, 5 more sevenths. Okay, so I have 11/7 plus 5 more sevenths. For a total of, there's 2 answers we could do here. There's 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 sevenths. Right? And we can see that 11/7 plus 5/7 is 16/7. Or the 5th grade level answer, we would recognize that this is 7/7 is 1 hole, 14/7 is 2 holes. So this is actually 2 holes and 2/7. Oops, I'm putting fourths for some reason. Now, these pictures aren't always necessary, but for some of you, they might be, right? Some kids can look at this and be like, oh, 14/7 is 2 holes, and then we have 15, 16, 2 more sevens, and they can see it. So the best 5th grade answer is 2 and 2/7. And again, some of you might not needed that. You might have just been able to see that here, but when you need it, you need it. All right, let's go to question 2, up the difficulty a little bit. Now we're using mixed numbers, which I've seen have caused a lot of problems and confusion for 5th graders. So I will draw this, although many of you don't necessarily need to. So let's see, if I have 2 cookies, 2 cookies and 1/5. Boom. So I have 2 and 1/5 cookies, and I'm going to add to that 1 and 6/5. Cut this into fifths. So we've got 1 cookie and 1, 2, 3, 4. Oh no, that's 5/5. I need another cookie because it's got to be 1 and 6/5. There we go. 1 and 6/5. What's the total here? Now, it might be funny if you look at these 2 pictures, they're the exact same amount. These are the same numbers. This says 2 and 1/5 plus 2 and 1/5, because we could take 5/5 like we did here and make it a second hole. So we have 1 2-hole cookies and then another 5th. So that's kind of funny. But when we add them together, we can see in our pictures, we can see that we have 4 holes and 2 more 5ths. So the best answer is going to be 4 and 2/5. But if you were someone who didn't draw the picture, you might have first done adding your holes. 2 plus 1 is 3. And then 1/5 plus 6/5 is 7/5. So you might have had that as your original answers, 3 and 7/5. And then you said, well, wait, 5/5, right? 5/5 is a hole. So that puts us up to 4 holes. And then there'd be 2/5 left because we took 5/5 away from the 7/5 to make that hole. So these are your 2 correct answers. This is the one we're looking for at a 5th grade level. Okay, let's try question 3. 3 says 1 hole minus 4/7. Some of you, a picture helps you see this. I'm going to draw a hole. Now I need to take 4/7 away. So I need to cut this into sevenths. 6 cuts make 7 pieces. And I started with a hole, and I need to take away 4/7. So the question is, how much do I have left? Well, I can see that there are these 3 pieces left. 3 pieces out of how many of those pieces in the hole? 1, 2, 3, 4, 5, 6. Oh, 7, because they're sevenths. So 1 minus 4/7 is 3/7. Now, I would like you, if you're trying to get away from needing to draw the picture all the time, then you might show this by saying, well, hey, 1 hole, I'm going to replace that with 7/7. And now 7 sevenths minus 4 sevenths, 7 minus 4 is 3, and the pieces are still sevenths. It's still what we had here. This was 7 sevenths, take away 4 of them, but now we're doing it symbolically. So you can, if you're ready for it, lean towards the symbolic. But I don't want you to just mentally say, well, 1 minus 4 sevenths is 3 sevenths, because it's good to do that in your head, but then you have to, for my purposes, show me the work, so I know you're not guessing. Okay. Question 4. This is the hardest type, okay? Now, generally here, we'll just take the wholes, subtract them, and the fractions and subtract them. But the problem is 2 fifths take away 4 fifths. We only have 2 of the pieces. How are we going to take away 4? We need more pieces, okay? Now, I'm going to do the picture first, and then I'll show you symbolically how I do this. This is going to be way easier and faster symbolically, but we want to make sure the picture makes sense. You don't have to draw this unless you want. I'm going to draw 3 2 fifths. 1, 2, 3, 4. So we have 3 wholes and 2 fifths. That's our first number. And we need to take away 1 4 fifths. Well, I don't need to redraw that. I can just take it away. I'm going to take away the 1 right here. Take away that whole 1. And then I need to take away 4 fifths. 1, 2. Oh, no. I need some more fifths. Oh, okay. There we go. 3, 4. See, I took away 1 whole and 1, 2, 3, 4 fifths. So how much left is shaded? Well, you can see in this picture that what we have left is 1 whole and 1, 2, 3 of these pieces. How many pieces in the whole? 5. So the answer is 1 3 fifths, okay? Now, most of the time it's not useful for us to always have to do this with a picture, even though that's what's actually happening in real life, but there are faster ways if we can use symbols to do it. And so we're going to show you what we did in this picture with symbols, okay? So if you didn't, oops, I'm going to erase my picture here and show you how to do this symbolically, which will eventually be faster and quicker, but you have to make sure you have good sense first. So here we go. There's 2 ways we could do this. The first way is what I would consider a method of regrouping, okay? So when I got to this point, I was like, oh, I can't do 2 fifths take away 4 fifths. I need some more fifths. Well, I could get one of those by taking a whole. Now we're down to 2 wholes. And in one of those holes, like remember in our picture, in 1 whole cake, there were 5 fifths. So when I took away this whole, I need to add 5 more fifths to my 2 fifths, which becomes 7 fifths. 2 7 fifths is the same thing as 3 2 fifths. Now I can subtract. 2 minus 1, right? I'm just doing the wholes first. 2 wholes minus 1 whole is 1 whole. And then 7 fifths minus 4 fifths. 7 minus 4 is 3, and the pieces are still fifths. See? Does that make sense? And again, I don't want to have to redraw my picture, but I will. I want to remind you, it's really important. 1, 2, 3, 4. I'm just redrawing 3 2 fifths so you can see it. I want to show you that what I'm doing symbolically isn't magic, right? 1, 2, 3 2 fifths, right? That's not magic what I'm doing here. 3 2 fifths is the same thing as, look, 1 whole, 2 wholes, and 1, 2, 3, 4, 5, 6, 7 fifths. 2 7 fifths is also shown in this picture. It's also 3 2 fifths, right? I can write fractions in a lot of different ways, okay? So that was the second way you could have done this. There is a third way, and so I'm going to show that to you right here. Some people like to do it this way, and some teachers actually lean into this exclusively as the only way. Some people like to change both of these to improper fractions. So for example, 3 2 fifths is the same thing as 5 fifths, 10 fifths, 15 fifths and 3, 16, 17 fifths. So 3 2 fifths is 17 fifths. And 1 3 fifths, I'm just going to use this same picture. 1 3 fifths, well, there's 5 fifths in 1, 6, 7, 8 fifths. That's the same thing as 8 fifths. So some people call this the improper fraction method. When they get mixed numbers, they'll change them both to improper fractions and then subtract. A lot of you do that when you're multiplying, which works for you as well. So 17 minus 8, well, 17 minus 7 is 10, minus 1 more is 9. 17 minus 8 is 9, but the pieces are still fifths. You might be like, but Mr. G, oh wait, did I do that right? Oh, I'm silly, dude. You see my mistake? This is 4 fifths, not 3 fifths. So this actually should be 9 fifths. Oops, 9 fifths. So 17 minus 9 would be 8 fifths. Now you might be like, Mr. G, wait a second. I thought we said the answer was 1 3 fifths, but you're saying that it's 8 fifths. Well, think about how much 8 fifths is, right? Like 5 fifths we know is 1 whole. So I can take 5 of those fifths to make 1 whole. But we had 8 fifths, so 6, 7, 8. We had 3 left. So we get 1 3 fifths, right? 8 fifths is 1 3 fifths. They're the same amount. Now, we prefer this as a simpler number, but this is also true and correct. So there we go. There were some different ways to do it. You could have done it with a regrouping strategy, or with an improper fraction strategy, like down here. You gotta know your fractions and your understanding of what they mean, and being able to picture pictures. It's true that after a while, drawing too much gets to be annoying, but it is what's truly happening in real life. Like, this is more what we're doing than this is. This is the symbolic way to show this. And so, yeah, eventually we just do it symbolically because it's quicker, but this is what we're actually doing. And so it's important that you see and understand that, or fractions will just keep feeling really, really hard. Now, probably this was not too hard for you. These are all 4th grade standards, and so we did those today as a review. Tomorrow, we're going to start upping the difficulty to 5th grade, which is, what do we do if the denominators are not the same? For example, if we were doing 1/4 plus 1/2, well, now the pieces are different sizes, so adding them and subtracting them doesn't really work. So we're going to figure out how to deal with that. Okay? If you have any questions, let me know, and good work.